Hello, this is Mrs. Huntley. We are learning about elimination today. We're still in Module 4, but if you remember, we stepped out of the Eureka material and we're in a supplemental packet that says Solving Systems of Equations on the front. And today we're going to be looking at elimination. Now the pages are not numbered, but if you're counting from the front of the book, it's about the 6th page in. Your top of your page should look just like mine. It says Solving Systems of Equations. And the essential question, what form does the linear equation need to be in order to use the elimination method? Another EQ might be how do you use the elimination method to solve a system of equations? So, first of all, both equations need to be in standard form-ish. I don't know if you remember standard form. We've talked about it a lot, and some of you really liked standard form. And when we were learning about slope-intercept form, we were kind of transferring things in and out of standard form and slope-intercept form. But standard form is where you have ax plus by equals c. And there were some rules about how a had to be. And the a term, whatever the coefficient was with the x, had to be positive and it had to be a whole number. So the reason I say that both equations need to be in standard form-ish is because the a term could possibly be negative. Our goal is actually to have opposite coefficients for one of the variables, either the x variable or the y variable. So sometimes that a term might be a negative. So it's kind of sort of in standard form, but maybe not the true standard form. So the second thing we have to do is line up the like terms. And again, you might be thinking, what? So let's do an example as we take our notes. If I have two equations in standard form-ish, and my first one is negative 2x plus 5y equals 7, and my second equation in the system is 2x plus 3y equals 9. I have like terms. I'm going to get a highlighter real quick. I've got positive 2x and I've got negative 2x, and those are like terms. And then I've got 5y and 3y. Those are like terms. And then I've got my c terms, 7 and 9. Those are like terms. So I've lined them up to where my x term is on top of my x term, my y term is on top of my y term, and my c term is on top of my c term. Now, that's the way standard form usually is. So it's usually lined up. So you're probably thinking, well, this isn't unusual for me. That's okay. I'm going to just put the notation out there so that we know that this is a system of equation. Our goal, I set up in number 1, our goal is to have some opposite coefficients. What are opposite coefficients? It's where the number is the same, but the signs are different. So you look at this first one here, negative 2x and positive 2x, those are going to be opposites. What's going to happen when I add these equations together is those are going to zero out, and the x term is going to be eliminated. So now I'm going to add the two equations together. Negative 2x plus 2x is 0. 5y plus 3y is going to be 8y. 7 plus 9 is 16. Now we have an equation that all of you can solve in one step. Divide both sides by 8, and we know that y equals 2. So that's our next note, actually. Wow, that's not what I wanted to do. Go. I want to solve for the remaining variable. So I eliminated the x term, and the term that was left was the y variable, and now I've solved for y. I know y equals 2. So I'm halfway done solving this system of equation. So my next step is to substitute that value back into either equation. It doesn't matter if I pick the first equation or the second equation. I'm going to substitute y equals 2 in place of y. So I'm going to take the first equation just because it's first. I play partials to first for whatever reason. So 2x plus 5, instead of y, I'm going to put a 2 in there, equals 7. Now I only have one variable. I can solve this for x and find out what my other term is. So negative 2x plus 5 times 2 is 10 equals 7. To get my x by itself, I'm going to subtract 10 from the left. Whatever I do to the left, I've got to do to the right. So I've got 2x, or negative 2x, I'm sorry. Negative 2x equals negative 3. I'm going to divide by negative 2, divide by negative 2, and x equals, a negative over a negative is going to give me a positive result. So I'll have 3 over 2, or if you do the division and you get 1.5, either way. So my x is going to be 3 over 2 or 1.5. They're both the same. My last step is to write my answer as an ordered pair. So in order to have my ordered pair here, my x term is 3 halves, my y term is 2. Now, there is a way for me to check and make sure that I've done everything correctly. Whichever equation has not been used yet, like I used the first equation in order to solve for x. So this was that equation that I took. So I can use this equation now for my check, the bottom equation I should say, for my check. So 2x, oops, I'm sorry, not x, 2 times 3 halves plus 3 times 2, does that equal 9? So 2 times 3 halves is going to be 3. 3 times 2 is going to be 6. 3 plus 6 is 9, and 9 equals 9. So I know I've done it correct. Okay, the next thing I want you to do is we're going to turn the page. The examples that are opposite the page that you've just been taking notes on, I'm going to use tomorrow. So I want you to flip the page, and you should be looking at this problem. Negative 6x plus 5y equals 1, and 6x plus 4y equals negative 10. That's the equation that we're going to attack first here. So this is a system. So I'm going to put that bracket there. We already have an opposite coefficient. If you look at, we're already lined up, I should add as well. If you look at the x terms, I've got negative 6, and then I've got a positive 6 that go with my x. And my y terms are lined up, and my c terms are lined up. So I can go about, oops, that's not what I wanted. I can go about adding these guys together. So negative 6x plus 6x is going to be 0. 5y plus 4y is going to be 9y. 1 minus 10 is going to be a negative 9. Again, one-step equation. Divide both sides by 9, and you should get y equals negative 1. We're halfway there. Take that negative 1, substitute it into either equation. Again, I'm going to pick the top one. So negative 6x, yes, I'm solving for x, plus 5 times negative 1 equals 1. So I need to find out what value of x will make this true. Negative 6x, 5 times negative 1 is going to be minus 5 equals 1. Add 5 to both sides of the equal sign. And negative 6x equals 6. Divide both sides by negative 6. And x is equal to negative 1. So x and y are negative 1. Again, I can check using the other equation. 6 times negative 1, is that equal to 4 times negative 1? And is that equal to negative 10? See, 6 times negative 1 is negative 6. 4 times negative 1 is negative 4. Negative 6 plus negative 4 is a negative 10, and negative 10 is equal to negative 10, so it works. What I'd like you to do is flip to the next page. That's your homework page. Your first homework problem is 4x minus 4y equals negative 20, and then negative 4x plus 6y equals 22. I would like you to pause the video and go about solving that problem. As you can see, we've got our terms all lined up. You didn't have to rearrange anything. And hopefully you're noticing that 4x and negative 4x are opposites. So at this point, you can just add your two equations together. So go ahead and pause the video and make sure that you're doing this work on your own. Alrighty, if you add the two equations together, you get 2y equals 2. To solve for y, you divide both sides of the equal sign by 2, and you should get y equals 1. Now take that y term, plug it in, substitute it into either one of the equations, and solve for x. Please pause the video and do that. Okay, when you solve that equation, or excuse me, when you substitute it in, I use the top equation. I have 4x minus 4 times 1 is equal to negative 20. Do the multiplication. 4x minus 4 is equal to 20, negative 20. Add 4 to both sides of the equal sign. You get 4x equals negative 16. Divide both sides by 4 to get your x term by itself, and you should get x equals negative 4. So the ordered pair, the answer here, is negative 4, 1. And again, I can check using the other equation. Negative 4 times negative 4 plus 6 times 1, is that equal to 22? Negative 4 times negative 4 is going to be a positive 16 plus 6 equals 22. 16 plus 6 is 22, and 22 does equal 22, so it works. Now I know you're saying right now, do I have to do the check? No, you don't have to do the check, but it will save you from making silly, foolish mistakes. So it's kind of up to you. That's not the part that's required. The part that's required is giving me this answer, that ordered pair that's going to make both equations true at the same time. If you don't check your work, you might make a foolish mistake. Also, use your calculators. Silly mistakes like integer errors or multiplication or division errors are costing you points on assessments. Since you can use your calculator, and then some other time go ahead and be practicing your integer rules and your multiplication rules. We're going to do another example together, and I'm actually going to erase some of this work because we just don't have space. So I'm going to erase this right here, and I'll leave the rest of the work. I'll just take away that, and then I'm going to actually put a line here. There we go. So we're going to do this top right equation together. I'm going to move this box over there. There we go. I have negative 2x minus 9y equals negative 25, and negative 4x minus 9y equals negative 23. I don't have any opposites. What I do have, which might be helpful to look at, is I've got some that's not good. Hang on, bear with me. I've got some like terms here. Negative 9y and negative 9y. My number is the same, but my sign is also the same. So I need to figure out a way that I can change that one of the negatives to a positive so that I can add them and that term is going to disappear. So I hope you remember back to the beginning when we were just learning how to solve equations, and we learned that as long as you do the same thing on both sides of the equal sign, you haven't changed the value of the equation. So I'm saying that if I take a negative 1 and I multiply both the left and the right side of one of the equations by a negative 1, I'm going to change the signs without changing the value of the equation. So I'm going to pick the top equation just because it can stay nice and neat that way. And I'm going to multiply that top equation by negative 1. So if I take negative 1 times a negative 2, I'm going to have a positive 2x. Negative 1 times a negative 9, I'm going to have a positive 9y. And negative 1 times a negative 25, I'll have a positive 25. So now I'm going to ignore the original equation. I've transformed it so that now I have some opposites. Now I can add them, and I'm going to eliminate my y. So negative 4x plus 2x is going to be a negative 2x. Negative 9y plus 9y is 0. Negative 23 plus 25 is going to be a positive 2. Now I can solve for x in one step. Divide by negative 2, divide by negative 2, and I know my x is equal to a negative 1. Positive 2 divided by negative 2 would be a negative 1. I use that negative 1, substituting it back into either equation. I'm again just going to pick the one on top because that's how I do it. Negative 4 times negative 1 minus 9y equals negative 23. A negative times a negative is a positive, so I've got positive 4 minus 9y equals negative 23. So I'm going to subtract 4 from the left side of the equal sign, subtract 4 from the right side of the equal sign, and I have negative 9y is equal to negative 27. Divide by negative 9, divide by negative 9, and I have y is equal to 3. So now I write my equation, or I write my solution as an ordered pair. My ordered pair is going to be negative 1, positive 3. I, of course, can check my work. I'll check it down here. Hopefully you didn't write as big as me. Using the other equation, I can either go back to the way it was originally or go back to the way I transformed it. I should probably go back to the way it was originally in case I made a mistake transforming it, that I would notice what my mistake was. So let me just see what that original equation was. And again, it makes no difference unless you made an error there. So we've got negative 2 times negative 1 minus 9 times 3 equals negative 25. Negative 2 times negative 1 is a positive 2. Negative 9 times 3 is going to be a negative 27. Negative 25. Positive 2 times or plus negative 27 is a negative 25. And negative 25 is equal to negative 25. So both sides of my equal sign are the same. And I know my solution is good. What I'd like you to do is do problem number 5 on your homework page. So let me insert another blank page. Problem number 5 on your homework page says negative 2x minus y is equal to negative 19. And the other one is 3x minus y is equal to 16. So again, we do not have opposite coefficients on either our x term or our y term. It would be relatively easy to do something to get our y terms to be opposite. So go ahead and do that. Pause the video, come back and make sure that you've done it correctly. Okay, I'm going to transform the top equation. So I'm just going to take the entire top equation and multiply through by a negative 1. Negative 1 times a negative 2 is a positive 2. Negative 1 times a negative 1 is a positive 1. Negative 1 times a negative 19 is a positive 19. I'm just going to remove this. And if you're like, wait, I'm supposed to be erasing things? No, it's just because I have the smart board, and it's easier for me to do it that way than it is for me to rewrite the equation. So that's how it should be transformed. Now I am good to go ahead and start adding my like terms down so that I can solve this system of equation using elimination. Please pause the video, do the next step, and then you can check back to see if you have it correct. Okay, when you add the two equations together, you should have 5x equals 35. Now to solve for x, one step should be easy peasy lemon squeezy. Go ahead and pause the video. Make sure that you are able to do this on your own. And x equals 7, so you're halfway there. Take that 7, substitute it back into either equation to solve for y. Go ahead and pause the video. Okay, I used the top equation and I substituted 7 in for the x and solved for y, and I got y equals 5. I can, of course, do a check and make sure that it worked. So does 3 times 7 minus 5 equal 16? Let's see, 3 times 7 is 21 minus 5. Does that equal 16? 21 minus 5 is 16, and 16 equals 16, so I know I've got that one correct. What I'd like you to do is attempt to do the rest of the problems on this homework page except 9 and 10. Now don't block out 9 and 10 to where you can't see the numbers anymore. We're going to tackle those probably tomorrow in class, but I haven't taught you something that you need to know how to do in order to tackle that type of problem. So skip 9 and 10 for now. I want you to be doing 1 through 8. We've already done 2 together. And I will tell you that on numbers 2, 3, and 4, you already have some opposite terms. You don't have to multiply through by anything in order to create your opposite terms. 6, 7, and 8, you will have to create your opposite terms by multiplying one of the equations by either a -1 or maybe a negative number. I think all of them can be achieved with a -1. So please, please, please do your homework. Send me an email or a remind message if you have any questions. And as always, have an awesome evening. I'll see you tomorrow. Bye.